Hello everyone, my name is Elliot Ryan and I have the pleasure of being the project manager for the TechSmith Worldwide Headquarters project. Prior to beginning this presentation, I'm going to go over a quick outline of what we will be discussing today. First, I'll get into the overall project scope and essentially what is being done on Michigan State University's campus. I'll then get into the SSD Engineering project goals and objectives and how we were able to successfully complete this project. I'll then get into each proposed design, which involves structures, transportation, pavement, hydrology, and environmental specialists. From there, I'll go over the complete project schedule from start to finish. I'll then go over the overall project cost estimate, which is separated into each subdiscipline's design and lump sum items. And lastly, I'll finish this off with going over the proposed design summary. To begin, the overall project scope. Michigan State University is redeveloping its Spartan Village, an off-campus housing neighborhood located on the west side of campus, into a technology and innovation campus. Spartan Village is approximately 140 acres and consists of various businesses that surround it. Our client, who is TechSmith Corporation, is looking to relocate their business onto Michigan State University's campus. TechSmith is currently located in Okemos, Michigan, which is roughly 10 minutes away from campus. The proposed two-story, 62,500 square foot headquarters building is being developed in partnership with the MSU Foundation. The building will be located on the corner of Crescent Road and Harrison Road on a 5-acre piece of land, as you can see in the picture to the right. Next, I'll talk about the project goals and objectives. Prior to this project beginning, the SSD engineering team sat down together to compile a list of goals and objectives. The reason for this was to ensure that we are going to provide a product to the client to the highest quality standard. Some of these project goals and objectives include developing an architecturally appealing building that upholds the client requirements. Some of these requirements include an ideal parking lot size, naturally lighted workspaces, and various break areas throughout the building. Next, establishing a low-impact stormwater management system that incorporates the nearby waterways, which in our case was the Red Cedar River. From there, redeveloping a pavement design that will incorporate and accommodate to the new increased traffic volumes due to the headquarters building being located on Harrison Road, which is already a naturally busy road. An emphasis on the Michigan State University's master plan, as well as the Michigan State University infrastructure and facilities plan into each subdiscipline's design is crucial. Assuring energy sustainability to meet the LEED Gold rating, which was one of the top priorities requested by the client. And lastly, maintaining the Michigan State University and the MDOT pedestrian safety standards, as well as providing modes of transportation to and from the site to ensure ease of transportation. We will now discuss the proposed designs from each subdiscipline. And to start us off, our structural specialist, Tina Wang, will begin to discuss her design.
Hello, my name is Tina and I'm the structural specialist for our team. I'll be discussing our preliminary building design. As Elliot mentioned, there are a lot of different requirements we have to meet from TechSmith. A lot of these have already been accounted for in the architectural plans we were given, and that's what our framing design is going to be based off of. So one of these is to maximize the natural lighting. We've done this by orienting the building so that the longest sides are facing the north and the south. We also need to include a shaded patio area at the front of the building, which is the south side over here, and an outdoor patio area that's going to be accessible through the second floor. We've done this by offsetting the first and the second floors, and at the right side over here, this is a plan view of the roof, and this blue outlined area is where that outdoor patio area would be going. And on the inside of the building, we need to account for a lot of collaborative open workspaces. We've done this by strategically placing our columns and selecting chevron bracing for our lateral force resisting system. This will allow us the most flexibility in where we're placing our doors, our walls, and our open areas. And also on the roof, we need to account for a mechanical unit, which is outlined in orange over here, a green roof that's going to be going on the east half of the building, and solar panels that are going to be going on the west side of the roof. And these are going to be adding some additional superimposed dead loads that we need to account for in our analysis. And finally, TechSmith has requested that our design achieve a gold LEED rating. And in the structural design, we can account for this by using some more sustainable materials. So for our girders, our beams, and our columns, we can use some recycled steel. And for the floor slabs that are going to be on the second floor, we can use some fly ash, some granulated blast furnace slag, and some carbon cure concrete in our concrete mixture. And this just means that for the carbon cure concrete, by injecting some byproduct concrete back into the mixture, we can reduce our carbon footprint and the amount of greenhouse gases that are emitted. These are the codes and standards that we're going to be considering in our design. We're going to be using the ASC 710, the AISC Steel Construction Manual, and the Michigan Building Code for the year of 2015, as well as considering the East Lansing building regulations and permits. We're going to be using these to decide what kind of loading we need to design for, the strength parameters, some properties of structural materials that we're going to be using, as well as other specifications. So from the codes, regulations, and standards we mentioned on the previous slide, we can then begin designing for some of our typical structural members. And this image is showing a typical bay and the tributary areas associated with it. So this pink crosshatch area is going to be the tributary area for a typical column. The blue is for a girder, and the purple is for a beam. We're also going to be assuming that the ends of the beams, girders, and columns are all pinned. We're not considering any of our lateral bracing yet at this point, and we're going to be using LFRD and heavily referencing the AISC Steel Construction Manual. And the loading that we're applying is going to be coming from the Michigan Building Code as well as the ASCE 7. This table summarizes the selected typical members that we got from our LFRD calculations. All of these are going to be made of grade A992 steel with a yield stress of 50 KSI. And as you can see, most of our columns are going to be W8 by 31, and a lot of our girders come out to have a depth of about 24 inches. After identifying our typical structural members, we can start drawing our general framing layout. So this is a drawing of the level 2 floor plan for area A, which is on the east half of the building. And this is mostly based off of the architectural plans that we were given earlier. And some things to make note of are the 7.5-degree offset up here and down here. This provides us with that shaded area that we wanted at the front, as well as gives us room to have that outdoor patio area that you can come out through from the second floor. It also gives a bit of like a sundial effect to the building. Another thing to make note of is that we've left a lot of openings in the framing for stairs, elevators, a roof hatch that's going to be on the west side of the building, as well as this atrium. One thing to note with the atrium is that the distributed load that would have been applied to these two bays is actually now going to be applied as a load around the perimeter of the atrium, and that might be affecting some of our beams in our analysis. So this is another drawing of our general framing layout, but this one is for the roof of area B, which is the west side of the building. And again, you can see that offset right here and right here. Between these dotted lines is where that outdoor patio on the second floor would be going. We also previously mentioned the roof hatch. There's a little opening left for that. And another requirement from TechSmith was to have a mechanical unit, which is located right here between column lines 9, 7, and C and D. Underneath these, the beams are going to be a little bit larger just to accommodate the additional loading caused by the mechanical unit. Also note that the west side of the building, area B, is dedicated for solar panels, and the east side is going to be for the green roof. Another thing we can do after we finish designing for our typical structural members that you saw a couple slides ago on that table is designing for our lateral brace in SAP 2000. This is more or less done through trial and error. So first we model a section of the building that includes the lateral brace, then we model our deformed shape, our axial diagram, our shear diagram, and our stress diagram, and through trial and error we can identify an appropriate double angle section. And some assumptions that we're also making here is that the boundary conditions are all pinned and all the connections are pinned. After completing our analysis for a typical lateral brace and structural members, we can generate one of these drawings that shows a portion of the lateral force resisting system. It also shows the loading that we applied in order to find those typical structural members. To summarize our structural drawings, we've completed loading diagrams derived from the ASCE 7, the Michigan Building Code, as well as other assumptions, and these loading diagrams accompany our framing plans for the second floor and the roof level. We've also completed a preliminary design for the lateral force resisting system. Moving forward, our transportation specialist, Jeff, will be discussing the details of the parking lot that's located just north of the building.
Hello, my name is Jeff Rockwell, and I'm the transportation specialist for this project. The transportation design proposed centers around a few key principles. As with any engineering design, safety is made absolutely paramount, and this project is no exception, and we'll get into that a bit more later in this presentation. This design is built to the specifications of both the City of East Lansing and Michigan State University. It considers a 20-year traffic projection for both build and non-build scenarios. Infrastructure for non-automobile-based transportation is made a priority as well. However, sufficient parking for employees and guests is considered. Finally, as requested by the client TechSmith, access to the Trowbridge Business Corridor is also made a priority. As I just mentioned, the specifications and codes considered for this design are given by the City of East Lansing, Michigan State University Infrastructure and Planning, and the Michigan Tri-County Regional Planning Commission. Now, the existing roadway design centers around two separate intersections that service this area. The first being the intersection of North Crescent Road in Harrison, which is a fully signalized intersection with all turning movements permitted with the exception of the northbound left turn onto North Crescent Road. However, South Crescent and Harrison is a non-signalized intersection and is only stop controlled in the eastbound direction. However, left turns are permitted for eastbound traveling motorists as well as northbound traveling motorists and is serviced via a crossover across the Harrison Avenue. And this raises considerable safety concerns, and we'll dig a bit deeper into that now. As you can see from this diagram, left turns from the northbound direction on Harrison onto South Crescent result in three separate points of conflict represented by the stars. Now, this is concerning for several reasons, but mainly they would likely result in a head-on collision with this other left turn, as well as 90-degree crashes with these two lanes of southbound Harrison traffic, which would likely result in serious safety implications, as well as the left turn movement out of South Crescent onto northbound Harrison would result in the same number of points of conflict as you can see, and the same types of crash as well, being two 90-degree crashes and likely a head-on collision there. So this was a main concern that was considered within the design, and how I have proposed to resolve this is by completely removing the crossover that exists there. And in order to then service the left turns from northbound Harrison, I have proposed an indirect left turn or Michigan left directly to the north of South Crescent with sufficient 250 feet of storage space to accommodate any sort of queue that may form and is controlled by a simple yield sign. However, in order to service left turns that would have previously been serviced by the crossover for eastbound South Crescent onto northbound Harrison, I've proposed for a second driveway to be built from the parking lot to the north and connecting with North Crescent. Those motorists can then turn right onto North Crescent and then left again onto northbound Harrison via the fully signalized intersection. So no longer would they have the safety concern of turning across 3 points of conflict. They will now have a fully signalized and protected left turn to reduce the possibility of crashes as much as possible. As you can see here, between the build and non-build for South Crescent, the level of service, in fact, improves in both the AM and PM, reflected in the delay and level of service. And this is extraordinary considering the increased number of trips that will be generated because of the new development and is a testament to the effectiveness of the design. Further, at North Crescent, the level of service does drop, which is to be expected with the vast number of increased trips as they accommodate for left turners that would have previously been serviced at South Crescent. Now, our sustainability features of this design, firstly, is a multi-use path that mirrors a lot of what is commonly found on the campus of Michigan State to service both pedestrians as well as bicycle traffic in two separate north and southbound lanes. The pedestrian path is 10 feet wide, and the bike lane in total is also 10 feet wide and divided into two 5-foot lanes. This path will travel parallel to Harrison Road and connect with the Trowbridge Business Corridor as requested by the client. Finally, our parking lot design features what's known as a vegetative bioswale, which will be gotten into a bit deeper by our hydrology specialist. However, it's a feature of the parking lot and allows for a more natural runoff of stormwater and ultimately slows the stormwater and allows for uptake within vegetation and plants, and ultimately decreases the rate at which water is then dispersed into our detention pond and is known as dampening the sharpness of the hydrograph. And again, that will be gotten into further by our hydrology specialist. Next, our pavement specialist, Jimmy, will get into the features of the pavement design for this project. Thank you.
Thank you for the introduction, Jeff. Like Jeff mentioned, my name is Jimmy Chadwick, and I'm the pavement specialist for the TechSmith project. And we're going to be going over some of the roadway requirements considered in the pavement design. We're going to go over the current climatic conditions that will control the project, analyzing the current and projected traffic demands, analyzing soil borings for subgrade characteristics for pavement design, and comparing some of the alternatives using a cost per lane mile, life cycle cost analysis using maintenance strategies. Prior to any new pavement design, I wanted to start by going over the local regulation standards and road municipality that's going to govern the road design for the project. As you can see on your screen, Harrison Road is the only road governed by the City of East Lansing, whereas Crescent Road, Middleville Road, and all parking design is going to be governed through Michigan State University's infrastructure and planning facility. Using these local regulations will help guide some of the design and technical standards that we're going to follow. But in addition, also going to be following Michigan Department of Transportation's standard for specification and also any special provisions on the project for any rehabilitation or anything like that, and also any material mix design as well. The first step of the pavement design is going over the environmental climatic conditions that are going to govern the road design. It's a critical step in determining some of the local high and low temperatures, the 7-day averages, as you can see on the table to the right. This data was found using the LTPP Bind online software, using the mirror data tool that basically generates this report. This is basically going to be used to help determine some of the viscoelastic properties for the superpave binder classification, and also analyzing the environmental impact that the weather could have on the concrete and asphalt pavements performance as well. The next step in the pavement design is going over the anticipated traffic demand and subgrade analysis. As you can see on the table in the top right, the average daily traffic and the corresponding equivalent single axle loading values for each flexible and rigid pavement. Basically, to start, the historical traffic data was found through the Trent County Regional Planning Commission, and that historical data was extrapolated using a 1.5 to 2% projected traffic growth. Harrison Road, being a more heavily populated road, was using the 2% traffic growth, and Crescent Middleville were using 1.5, whereas all parking design was found using the geotechnical report as seen in the bottom. Standard MDOT truck factors were used for flexible and rigid pavements of 0.88 and 1.39. A commercial vehicle factor of 3 to 5%. That's accounting for some of the heavy traffic that's going to be coming through there, including buses as well. And then using the traffic data and the environmental data shown before, a super paid performance grade of a 6422 will be used for the project. And then in addition, as you can see on the bottom right, going over the subgrade reaction and resilient modulus for the design, going over the soil borings, everything was pretty much the same for all the borings, pretty much the same USCS classification being a CL, sandy clay with silt and trace gravel. And per the geotechnical report, it was advised that a California boring ratio of 3% were to be used for the project, and a corresponding resilient modulus of 1400 or 4500 were to be used for the project as well. Now we're going to be going over the pavement condition survey for the project. This is basically to help determine what rehabilitation technique to use based on some of the serviceability indexes that we found and some of the rehabilitation that we're going to be using. As you can see on the bottom left, that is a screenshot of current Harrison Road in the project scope. As you can see, there is some medium to high alligator cracking in the wheel path. This is indicating of some future rehabilitation in the near future. Whereas at the top right on Crescent and Millville Road, there is some longitudinal joint cracking. I mean, it's basically along the entire road length, but we can see there's some overband crack sealing on top of it. So I mean, it's probably keeping that crack shut. But as I found, there is a scheduled rehabilitation within the next few years, so that could also be included into the project as well. The next step in the roadway design is going over the rehabilitation material quantities. Before we go any further, it was decided that the resurface mill and fill was found to be the most cost effective using the cost per lane mile analysis and the life cycle cost analysis using maintenance strategies. It's just the most practical option to use. I mean, the overlay option, you'd have to change the vertical profile, and just new construction is just overall way too expensive for what is needed for this project. So as you can see in this table, some of the geometric requirements for the project for Harrison Crescent and Millville Road, that is also including a couple columns for the bike lanes as well. Kind of just getting an idea of where some of these cost estimates are coming from. Basically just want to look at this bottom row here where it's kind of showing the tonnage that's going to be used, and also a standard 2-inch mill and fill depth with a 5E3 mix. That E3 mix is basically found using the traffic data that we found, that ESL range was in between 1 million and 3 million, and the performance grade being a 6422. That is just the most practical mix to use for this project as well. In addition to some of the rehabilitation that's going to be considered for the project, there is some new design considerations for the project, and on this slide is kind of a table form of some of the material that's going to be used for that. That is used using the AASHTO 9386 method. On Harrison Road, there is a new Michigan left turn lane and concrete sidewalk implemented by the transportation specialist. And like the previous slide, this kind of just shows some of the requirements and some of the cost estimations that's going to be found in the later slides. And on Crescent Road, there is the driveway approach showing the asphalt tonnage and the base curb and gutter also as well. All these materials were derived using MDOT's LCCA unit price sheet. And then finally for the parking lot, there's just the asphalt concrete parking lot itself and the concrete loading and unloading zone as well. Also showing the curb and gutter for that as well. Now we're going to be going over the roadway cost breakdown. As we can see in this table below, this is the total cost for the pavement section of the Texas project. It is broken down into each road and the corresponding rehabilitation or new construction method. For the material cost, I mean, for the rehabilitation, that's just the material cost for the asphalt, the 5E3 mix. And for all new construction for I guess for Crescent, it would be the new approaches, and for Harrison Road, it'd be the Michigan left and the sidewalk. For the construction cost, though, that's going over basically the cold milling costs and pavement cleaning. And for new construction, it's all the excavation that's going to be provided as well. As we can finally see, it comes about to about $900,000, and that is the total cost of the pavement section. Now, just as a reference, this is some of the cross sections that I'm going to be using for the project. So to start, this is the proposed resurface on Crescent, Middleville, and Harrison Road. As you can see at the top, the only change is the proposed bituminous resurface top course being a 5E3 mix, and everything else below it is staying the same. This is going to be the cross-section for the proposed reconstruction. As you can see, the top course, leveling course are changing to the 5E3 and the 4E3 leveling mix. Everything besides that is basically staying the same. This is going to be the proposed cross-section for the parking lot. It is just 2 lifts of low-volume super paved. Mixed design is going to be low volume per the geotechnical report, and standard ag base and sub base will be used. And then the subgrade will be sloped 1% towards the bioswale, which we can talked about more with our hydrology specialist as well. And then this is the cross section for the loading and unloading zone for the concrete, reinforced concrete pavement in the parking lot. As you can see, it's consists of 3 pours with the reinforcement in between each of the pours. And other than that, everything is staying pretty much constant with a 2-inch aggregate base. And finally, this is the proposed concrete sidewalk that will be used for the project, just a standard 6-inch pour, no reinforcement, and a standard 2-inch base course as well. And now going forward, we will be talking about with our hydrology specialist, Sarah, and she's going to guide us through the next portion. Thank you.
Hi, I'm Sarah Nevedal. I am the hydrology specialist for our team. My goal was to design a stormwater management system for the TechSmith site. My motivations were low impact development, as well as reducing flooding and runoff from the site. A little overview of my design. There is a rain garden here, which is the green box on the southeast corner of the site. Just this one subcatchment surrounding it drains there. All of the other 10 subcatchments drain to the northeast corner where I have a detention pond. Both the detention pond and the rain garden are placed at low elevations so the water could naturally flow. There are 6 subcatchments that break up the parking lot. I chose to add that many because the parking lot is the most impervious surface, so there would be the most runoff. There's also a bioswale that Jeff mentioned earlier in the middle of the parking lot, which is this green box here. I placed that there to help with drainage as well as filtering out water before it goes to the detention pond. The 2 main sources that I use for regulations to govern my stormwater management system were the rules of the Ingham County Drain Commissioner and the MDOT Drainage Manual. Some of the main regulations that I used were that subcatchments had to be less than 400 feet apart. I based my sewer and pipe design off of a 10-year, 24-hour duration storm, and the detention pond based on a 100-year, 24-hour storm. I also used the Ingham County rule that the discharge from the detention pond has to be less than the runoff before development, or 0.15 cubic feet per second, which I ended up using because that was less than pre-development runoff. I also based the velocity running through the pipes and the bioswale off of what is given in the Ingham County Drain Commission. My main motivation of my design was low impact development and being as sustainable as possible. One way I did this was following the natural topography of the site so that water could naturally flow to my drainage areas. 2 drainage areas that I have pictured on this slide are a bioswale and a rain garden. These 2 are both on MSU's campus currently. I chose these 2 so that the ones that are added to our site would stay with the aesthetics of MSU's campus. I chose to do a bioswale and a rain garden because they naturally filter water before it goes back into the ground. It filters out pollution and sediment. They also both have natural vegetation that is natural to the local area as well as have extensive roots so it can absorb as much water as possible. This is a win-win because it adds a natural green space and it filters out the water. One of the main aspects of my design was the detention pond. For this, I chose the shape of a truncated cone, so it is flat on the top and the bottom and sloped to a smaller radius on the bottom. I chose this because the County Drain Commission says that a detention pond has to have a slope of at least 4 width to 1 height for the safety of people around it. I chose to do the pulse method to reduce the discharge of the detention pond. As I stated before, County Drain Commission says that the discharge of a detention pond has to be less than it was pre-development or 0.15 cubic feet per second per acre. For me, the 0.15 cubic feet per second per acre was less than the pre-development flow. For my site, once I multiplied that number by our total area, it ended up being just a little bit below 1 cubic feet per second. As you can see in the graph on the right, the blue hydrograph was the inflow of a 100-year 24-hour duration storm, which is way greater than the 1 cubic feet per second maximum allowed flow. So with the pulse method, I changed the outlet pipe size and the size of the detention pond until it was great enough that it could store water long enough and have a small enough discharge that it was always less than 1 cubic feet per second. This orange line is the outflow. It took about 50 hours of storing the water so that it would always be less than 1 cubic feet per second. The total volume of the pond ended up being around 45,000 cubic feet. And I also added 10% extra volume to the bottom so that there could be a sediment forebay. This collects sediment and pollution before the water is drained to the existing pipe that is put in by MSU.
Hello, I'm Abby. I'm one of the environmental specialists on the project. To start off here, the task of the environmental team throughout the duration of the project was to design upgrades to the East Lansing wastewater treatment facility. The goal of the designed upgrades was to effectively remove phosphorus and nitrogen from incoming water to avoid damage to aquatic ecosystems that are a part of the Red Cedar River, which is where the affluent water goes. The images on the screen here show the setup of the current East Lansing wastewater treatment facility without the planned upgrades. Their current setup that they have now includes a primary clarification system, a secondary clarification system, tertiary filtration, and activated sludge treatment. The upgrades for the design include a nitrification process for nitrogen removal. This process was added just after primary clarification and before secondary clarification, so right about here. Also, a ferric chloride addition for phosphorus removal was added just after secondary clarification here. And the anaerobic digester was also added to this design for the purpose of carbon capture and the potential reuse of methane for power. The nitrification process consists of 2 tanks. The first and larger of the 2 operates under aerobic conditions to allow for influent ammonia to be converted to nitrate. The smaller second tank will operate under anoxic conditions to allow for sufficient conversion of nitrite to nitrate. An addition of carbon is required before the water enters the anoxic tank, roughly 2 tons per day. This allows for the reaction in the anoxic tank to dramatically decrease the amount of total nitrogen in the effluent. For phosphorus removal, our design includes an addition of roughly 3 tons of ferric chloride per day. After the addition of ferric chloride, the addition of a sand filter was also necessary for backwash. The backwash function was put in place to ensure any leftover or any additional that may have been picked up during the process of nitrogen or phosphorus or suspended solids, that we're making sure that those are removed. After a simulation with the program Sumo 19 and with the design of the aerobic and anoxic tank pair, we were able to reach total nitrogen values for effluent water of about 1.3 milligrams per liter. In the image here on the left, that is the image of the simulation after about 100 days, showing that the total nitrogen in the effluent is 1.3 milligrams per liter. Additionally, as seen here on the right, after the simulation of effluent phosphorus levels were approximately 0.4 milligrams per liter. Again, in the image here on the right, that's the total phosphorus after the simulation of about 100 days. Both of these values were well within the government-provided regulations and the design-specific goals we had in place for this project. The other environmental specialist is now going to talk on the rest of the additions.
Hello, my name is Dante Richard, and I'm the other environmental specialist assigned to this team. I'll be discussing the last notable addition to our wastewater treatment facility, the anaerobic digester. The anaerobic digester specifications that we have chosen to fit our needs has a total storage capacity of 1.3 million gallons as well as a tank depth of 10 meters. This anaerobic digester serves a great purpose within our facility as it utilizes the organic matter held within the sludge produced and converts this organic matter to pure methane through the digestion process. This methane recovery system is a critical step within our facility as it gives the facility the ability to produce energy by burning this carbon source. Next, I will discuss the regulations that we followed to accomplish this project. To achieve effluent water with acceptable contaminant concentrations, we followed guidelines under U.S. Code 1316, National Standards of Performance under the Clean Water Act, as well as U.S. Code 125, Technology-Based Standards. Specifically, Code 125 dictates the biodegradable oxygen demand, as well as the biodegradable chemical oxygen demand, or BOD and BCOD limitations for wastewater. We met these limitation guidelines for BOD, which are an average of 45 milligrams per liter weekly and 30 milligrams per liter monthly. And for BCOD, the limit is an average of 25 milligrams per liter weekly and 40 milligrams per liter monthly. Rule 60 of the U.S. Code 1316 sets limitations for plant nutrients like nitrogen and phosphorus. Rule 62 sets limitations for organisms like E. coli and other bacteria. The limitations set for phosphates are no more than 0.05 milligrams per liter for streams discharging into reservoirs like the Red Cedar River. The limitations set for nitrates are up to 10 milligrams per liter, which is intended to be under the contaminant levels associated with blue baby disease. We achieved a nitrogen level of 1.29 milligrams per liter, which is a greatly reduced number from 10 milligrams per liter set by the EPA. A major goal of this project was to produce effluent water of greater limitations than those posed by the EPA. By removing more of these contaminants, we hope to alleviate environmental stressors and produce effluent water with a high quality. Low quality effluent water can cause issues like eutrophication, death of animal life, as well as habitat loss. The design and implementation of a wastewater treatment facility is a costly process. For most of the design criteria that we had planned, information online was not readily available in terms of cost estimations. For example, our anoxic tank, which has a storage capacity of 7.9 million gallons, is not easy to purchase, and for that reason, we had a hard time finding data on cost estimates for most of the structures used. For this reason, we used industrial-sized cost data from distributors online for structures like the anoxic and aerobic tanks used. With this information, we calculated our total to be $124 million estimated. It should be noted that the ferric chloride and methane cost used in this estimate are yearly, and each structure used and estimated for has a 10% installation fee charge as well. When we calculated the cost of things like ferric chloride and methane, we came to a rough total of $95 million. This left us with roughly $29 million to use on parts with high variability based on location. Things like the aerobic digester, which doesn't have a lot of information online for cost, as well as waste removal and collection, maintenance, and piping, would be purchased using the remaining $29 million in our budget. Now, our team leader, Elliot Ryan, will discuss the project construction schedule as well as the overall cost estimates for the TechSmith construction project.
I will now get into the project construction schedule. As you can see in the picture here, the demolition is set to begin on April 4th of the year 2022, and the end date of this project is set to be May 31st of the year 2023. As you can see here, the various phases of the project have been assigned to be completed in months that will allow little to no issues. For example, the foundation, the stormwater system, and the framing of the building will be completed in the warmer months of the year. Along with that, road reconstruction, the parking lot, and sidewalks will be poured at a similar time of the year. Next, the interior will begin mid to late August and is expected to end early May of the year 2023. And then lastly, the project completion will take roughly 23 days for project cleanup and landscaping around the building. As you can see here, this is the overall project cost estimation. The two separate tables include, first, subdiscipline cost estimation, and second, the lump sum items. The subdiscipline cost estimation can be seen at the top, split into transportation, structures, hydrology, pavements, and environmental. However, it is important to note that the environmental upgrades cost was not taken into account due to the fact that their design was not directly tied to the TechSmith headquarters building project. The design specifically was meant for the city of East Lansing, which will help the TechSmith headquarters at some point. Some of the lump sum items include mobilization, fees and permits, as were discussed earlier, traffic control devices during the road reconstruction, contract staking prior to construction, project cleanup, and landscaping around the building. Along with that, there will be a 10% contingency to have an overall project cost estimate to be roughly $15,206,000. I will now summarize the proposed design summaries. To start off, as discussed earlier, the structural specialist has designed a steel frame, two-storied, 62,500 square foot headquarters building for the client TechSmith. This building will include 3 staircases, an elevator, break areas, conference rooms, and obviously multiple workspaces. To ensure that we meet the LEED Gold rating, we have installed solar panels on the flat roof, and we will be installing large windows to ensure natural lighting throughout the building to minimize electricity use. The transportation specialist plans to remove both existing crossover intersections along Harrison Road. Doing so, he will be installing an indirect left turn with a turning lane. Also, he's installing 2 driveways that will connect the parking lot to both northern portion of Crescent Road and the southern portion of Crescent Road. Along with that, he will also be installing a bike/scooter/walkway that will allow ease of access to and from campus. The pavement specialist has found Super Pave Mix Design PG6422 to be the most efficient for the increased traffic volumes and ensuring a design life that it will be very long. The most economical rehabilitation method was found to be mill and fill resurface for each road, including Middlevale Road, Harrison Road, and Crescent Road. The hydrology specialist will be installing a detention pond and as well as a rain garden next to the building. Along with that, she will be installing a bioswale that has been incorporated into the parking lot to ensure proper flow of water. Lastly, our environmental specialists plan to upgrade the East Lansing wastewater treatment facility for the removal of phosphorus and nitrogen and for the recovery of carbon which enters the plant on a daily basis. On behalf of the SSD engineering team, we want to thank you for listening and we hope you have a wonderful day.